Spatial pyramid pooling allows you to take as input images of different sizes and to output a fixed size representation. This is very useful to deal with images of different sizes. Let us look at the picture. On the bottom, you have an input image to which you apply convolutions. You obtain a volume of depth 256. Three types of pooling are then applied. Unlike the pooling we have seen so far, we do not specify here the size of the window, but we specify the number of squares we consider in the feature map. For example, the pooling on the right corresponds to 1 square and outputs the maximum of all values in the given feature map. The pooling on the left corresponds to splitting the feature map into 16 regions, which outputs 16 values. Regardless of the size of the feature map, you always obtain the same numbers of values output by these pooling layers. You can then concatenate those values into one big vector of fixed size. Spatial pyramid pooling can be used inside a network in order to deal with images of different sizes as inputs and obtain a representation of fixed size for each image. This is particularly relevant for classifying region proposals since images of different sizes may appear. We mentioned a major drawback of RCNN, which is a multi-stage pipeline, because the CNN feature extractor and the SVM classifier are impossible to train jointly. Faster RCNN uses an end-to-end training method. All network layers can be updated during fine-tuning, region proposals, and final classifier, which improves the learning process and the overall accuracy. Attention mechanisms can also be used to improve the accuracy of such networks. More recently, two methods, YOLO and SSD, have been drawing a lot of attention. They are single pipelines detections that directly predicts class labels. YOLO, standing for You Only Look Once, treats object detection as a regression problem to spatially separate bounding boxes and associated class probabilities. SSD, standing for Single Shot Detector, discretizes the output space of bounding boxes into a set of default boxes over different aspect ratios and scales per feature map location. With this multiple scale setting and the matching strategy, SSD is significantly more accurate than YOLO. More involved approaches exist, like that of Lu et al. In 2016, who proposed a top-down search strategy to divide a window into sub-windows recursively, in which an additional network is trained to account for such division decisions.